So, hello everyone, welcome again to another riveting, exciting episode of the most boring podcast ever, Hazardous Area Safety. Today I've got Michael Marrington with me, and would you like to introduce yourself, Mike?
Sure. Michael Marrington. I work for and run and operate Index Hazardous Area EX Professionals. I am a electrician by trade originally. I worked my way into instrumentation, mechanical engineering, and have been working within hazardous areas for about 21 years.
It's a fairly long time. I bet you've seen some pretty interesting stuff during that time. So is it mainly offshore stuff that you've done, or give us a bit of experience with your background as far as hazardous
So a
area
mixture of
safety?
things. In Canada, so I lived in Canada until 2010. So from 2004 to 2010, did a lot of Canadian oil sands. So it's mining and oil and gas all in one. Also within there, so a lot of mining industries, petrochemical, cement, wood industry, common traditional industries in Canada. And then I migrated to Australia, got the Australian passport and everything. So came down 2010 and worked in mining and once again oil and gas. And as part of that, as you probably know, Travis, a lot of projects are actually built overseas for Australia. Everything's modularized. So that took me overseas. And with that, did a lot of working at the vendors' facilities, and then also involved, I started working offshore, doing inspections and maintenance stuff. And as of about 2017, I eventually started taking fixed overseas jobs, such as is in Kazakhstan, and met the managing director of Index, the owner of Index at the time. And from that point onwards, I started working much more varied gypsum industry, so drywall, the walls, cement industry, food industry, sugar, agricultural, still oil and gas. That's still the major bread and butter. But yeah, anywhere there's gas, vapor, liquid, ducts, fibers, lines, anything that's combustible. And at this time, I haven't really acted as an electrician in 12 years, but have been doing the inspections, the audits, the hazardous area classifications, consultations. So, upgraded from the average electrician.
So you've hung up into a little bit, so to speak.
Yes.
So with that, because one of the things that surprised me, specifically around Australia, is we have this notion, and considering with equipment installs and equipment inspections. Now, I've seen personally, when I've reviewed verification dossiers, that you have the same person who does the installation also does the initial inspection. What are your thoughts about that?
Can be a conflict of interest, but it really comes down. So ISO 17020, that's where we find the definitions of first party, second party, or third party inspections. Typically, the first party inspections, so done by the same person or same department of a company, they're typically not going to do inspections properly. They will be impacted by human factors of hurry up and get it done.
Yes.
And so they typically will not get caught out on the QA/QC, quality assurance, the documentation, procedure issues, and the quality control issues, the things they should have caught. So they're probably not catching all the QA issues, all the documentation issues, doing the proper as builds, red lines, and QC, you're expecting them to self-report. Now, they may catch their problems, but do they write it down in a report that I made this mistake? This is wrong, and here's the correction? No. So all that data, statistical, that could be used for statistical analysis, is completely missing. And this is, we know we do this ourselves in our lives. We go by memory. We don't report all of the negative things we've done, right? All the mistakes we've made. So
That's
I believe that installers should not be allowed to do the initial detail inspection, but they do have to inspect their own work. They must back off the gland and do a visual inspection, but not do the initial detail. That's my opinion.
that's a really insightful thing that you've just said, because it's more like it's explaining to installers, electricians, technicians, whoever's doing the installation, that they are responsible for the QC and the quality assurance of the installation that they've done. But the initial inspection portion of it, that's a different kettle of fish. You can have a buddy system. I don't mind smaller companies having a buddy system. Employee A doing the installation, employee B doing the initial inspections, and then chopping and changing it as you go down the production line or whatever the project is. Yeah, I have reservation when I see, the same person who's done the installation, the same person that's installed the device, the same person that's done the initial inspections. You're just using that as a tick and flick sheet. I highly doubt that you've actually done your due diligence to actually look at the documentation to make sure that you're in, even a simple case of, I've seen it time and time again, like the introduction of impact drills onto some sites like that are hazardous, but while they're in the construction phase, and you see guys just snap on the socket's head and just start smacking down the faceplate of the EXD box. It's just heartbreaking. It's kind of like, guys, there's $4,000 that you just ruined because you can't go out and buy a tool wrench.
Yep. Yeah, it's with a smaller company, obviously, then the procedures need to be solid. If the company had good procedures that makes things easy to understand, or even ITRs, inspection test reports, so you can have construction ITRs, right? Not even at the QA/QC phase. You have construction, QA/QC, but not every project has QA/QC. Maybe it's built into those different phases. But many of the problems that I see with these ITRs, maybe they're created by an engineer, and okay, it asks you for insulation resistance, Megger value. They don't give them the test parameters, and they don't give them the acceptable values typically. So we see on many projects, if you're electrical heat tracing, you're doing self-regulating cable, the flexible cable. The minimum is 500 volt DC test, but the standard and the manufacturers say you should test at 2500 volt DC. And it's shocking the amount of electricians that don't understand that the higher the voltage means the higher the pressure. So if you have a sewage line or a gas line, you want to pressure test it, typically up near the maximum design pressure, so that you can find the leaks. Same thing for electrical. We're putting more pressure, more voltage to find the leaks. And if you don't tell them this, they're not going to do it. If it's not on the ITR, if it's not on the instructions, they're not going to do it. And then what's the acceptable value? So we've been on many projects around the world, Canada, Australia, Kazakhstan. It's the same problem. Unless somebody that is practical makes the forms also like a procedure, we'll be always wasting a lot of time doing documentation where maybe you won't get the statistics. You won't find the faults unless you tell the people how to do the test on the sheet and the acceptable results on the sheet. You want to empower to do things correctly, but also for them to see if there's an issue. You want your people to speak up. But if your documentation or your instructions are verbal or a very basic sheet for here's the table, go fill it in, laziness from the top, from management, I would say. And that's an experience I've seen on many projects.
I think we're going to unpack this one now. So we're going to go down this rabbit warren because it's quite a big one, and you've just touched on a very, very pertinent issue that happens within, well, I feel personally, within hazardous areas. So to start with, if we break it up, we've got an understanding of the correct terminology. We've got an understanding of what the parameters are, what measures success. So like what we're going to comply to, how that is nominated by a company for their parameters of quality assurance through an ITR, and you've got the training and how that's disseminated through that company to its team members. So within Australia, there's a misconception. Use the word mega, and that's synonymous with an installation resistance test. So the reason that we utilize mega as the word on how to deal with the testing, because back in the day, mega was the leading brand of suppliers of installation resistance tests. Everyone had a mega, like it's what it was, and it would be the same. If if it happened today, you'd be calling it a fluke test, kind of. But so many electricians don't understand how to conduct correct testing, because they don't. They go to the standard, in my experience, and they're looking at the standard to get them the magic answers that they need, instead of understanding the context of what they're trying to achieve. They're going, okay, well, what are the parameters of success for this? What does the standard actually do? How is that being utilized in our day-to-day work? What are we trying to set up for? Where are the results that we need to get? And are the results in line with the manufacturer's specs as well? And so that's been my experience within the industry at a regulatory space. And it's just, people go, well, hook it up, it's on an RCD, we'll just make sure that it's operating, onto the next one, quick, onto the next one, rush. And that degrades everything, because there's that anxiety around deadlines, anxiety around work effort, deadlines, around project cost or project blowout. And so the time needed to build rigid and robust systems and robust process and support systems for training are oftentimes just overlooked. And then it's just, okay, inherit it, handball it, here's your fat test, here's your document, see you later, work, packing up, so we're off to the next project. So what are your thoughts on that?
Each country has a different way of training. For example, electrical is a 3-year apprenticeship in Australia, while in Canada is a 4-year apprenticeship.
It's 4 years here.
But 3 in WA, it's achievable within 3 years.
Depending if you've done your pre-vocational training for it. But yeah, it's typically it's 4, because you have to have your profiling.
Yeah. So there was a lot of guys that I worked with throughout WA and Northern Territory that finished within 3 years. So I also did I'm forgetting what the name of it is at the time. I had to do my a 2-week course when I first came down to Australia to learn that a GFCI in North America is an RCD for you guys.
Yeah.
We trip at 5 milliamp, you trip at 30 milliamp. We have AFCIs, AFDDs only came into your standards via 2018 edition of AS3000. So in some way, there's differences, but they're the same, but how they're applied. So in Canada, I'm very lucky that it's a very structured schooling of 10 weeks every year. You had to go to school for the 4 years. And it was full time, 8 a.m. to 5 p.m. for 10 weeks straight. So there's that. There's also pre-apprenticeship built into high school, so that can get you a head start. But also during our apprenticeship, we're allowed 4 apprentices for every tradesman.
Yeah.
So a tradesman learns how to be a supervisor and trainer because they're taking care of poor people, right? So within Australia and UK and other locations, you're only allowed 1 apprentice per. I personally believe that is a negative against the electrician. He's not learning how to be a supervisor based on my personal experience from being around the world.
That's the reason that it's portioned in. It's not for a supervisor. It's not for training the tradesman. It's just to make sure that the apprentice has it just makes sure that the apprentice has the right adequate level of supervision while he's going through their apprenticeship. So that's
Correctly.
what it's designed for. So it's designed to make sure the
Un, un,
ratios are correct for an incident reporting incident to occur. Was that apprentice, if an incident happened, was
yeah.
that apprentice adequately supervised within the company?
Unfortunately, all the work in the UK and Australia and other locations that an apprentice would have used to have done in the past has now been fallen onto the shoulders of TAs, trade assistants.
Yes.
So this ratioing has now resulted in apprentices not learning how to do cable trays, pull cables, do earthing, grounding, and bonding. So this, how would we say, trying to fit a square peg into a round hole that I've seen that has happened internationally has resulted in electricians that don't know how to train anybody because they maybe had an apprentice and they haven't trained them so much. Like, hey, why do I need to put joiner plates on a cable tray? Why do I have to have an expansion plate? Expansion, contraction, earthquakes, whatever. But what they don't learn that they have to put bonding between each jumper point. They don't understand that each joint in a cable tray, you must have a bond, and each end of the cable tray must be bonded to the underground grounding system, because the moment a section of tray is removed, you've lost your conductivity, right? The bonding of that entire line.
So
And
a good point that you've raised with that, because a lot of there's like garbage in, garbage out. I'm not saying that for the general industry, but I'm just saying that there's a training deficit because there is a inherent how do I put this correctly?
I would say that electrical experience is being invested into those who may change industries. So the trade assistants, I would say that experience is being lost or eroded away, and it's not going into the electrician, it's going into a TA who is more likely to leave the industry.
So I also started as an electrician, and back when I was a boy, back when I was an apprentice, I remember asking one of my tradesmen at the time about the workings of an RCD, about the inner workings of a residual current device. And I think it was the second year at the time, second or first year, can't remember. And I remember this quite vividly. He turned around and he said to me, "Don't ask me, that's what TAFE's for. Like, that's what the training school's for. Don't ask me." So you've got this like attitude. That's probably the correct word. You've got an attitude within some players. I'm not saying within all, because some companies have an excellent training program, excellent continual professional development program. They do spend a lot of time and a lot of resource into upskilling their tradespeople, but you have, in some aspects, you have the onus is you are there to work, you are not there to be taught. And so it's kind of do what I say now, because we have to get this project done so that we can get on to the next one.
And that's the cultural difference that I saw between Canada and Australia and other locations. Well, in Canada, like, Australia is great where you get a lot of practical experience and you have flexibility, right? In doing your different certificates. Canada is woefully 40 years behind compared to people can move up through the Australian qualification framework. You can go from an electrician to a project manager even while still working. While in Canada, you would have to take 2 years off, or you have to work in the city and do night school. And FIFO culture is common in Australia, while in Canada, people, the schools can't understand. The theoretical training is very good in Canada, very good. But there were practical exercises were not practical at all. But it is an expectation that you gain all the practical experience out on your job. So your journey, it trains you. And so when he has 4 apprentices, he's learning how to be a supervisor, a trainer, and a project manager all at the same time. So they are breeding electricians. Not, obviously, not all of them are going to turn out to be good supervisors. Some are just going to be lighting and receptacles, GPOs, for the rest of their lives, right? But it does give them the perspective of, hey, they're running a crew of 4 people. They're responsible for everything going right or wrong, and teaching them practically. That and then what you just said, a tradesman going, it's not my responsibility. And I see that, because they have one person under them. They're not really taught how to be a supervisor or a like the electrician is not expected to. They're not experiencing being a trainer, a supervisor, or a project manager. They just have a buddy. Hey, go grab me this, grab me that. Is go for this, go for that. So I found that doing my electrical apprenticeship in Canada, I was very lucky that it taught me these other perspectives. And I do see that it's lacking in other locations, but I'm not saying it's common all the time out of Canada or common. So I'm not bagging on one or the other, but I am saying I found a lot of personal benefit from what I experienced. But then if you go to other countries, let's say the US, 50 states, hundreds of different ways of doing things. They have tradesmen, journeymen, conduit fitters, or fit out electricians. So all they're doing is installing the light and the GPO. They're not doing the wiring or doing the boxes, right? So I realize this. And then when you get to shipyards, a lot of times, if you're in Southeast Asia, a lot of the shipyards are just full of the people they pulled off the street or off a farm to do the electrical. It's how do you get them to do things right? Well, you have to be a good trainer. Show them how to do a cable gland, or show them how to insulation resistance testing, measuring. If you know how to communicate memes, text and pictures and text, and create a little guide of how to do something, or show them a video and then give them a supporting visual document, somebody trained you well to communicate well. But if you're just telling your apprentice, go to school, you obviously don't know how to communicate well. You don't know how to. So that's a personal experience you shared, and it's ones that I've seen. But I'm not saying that of everybody, obviously.
No, like as I said, like there was some trade, like, and when we have conversations like this, it's quite difficult to relate to an incident that happened X amount of years ago from my side of the fence as well, without hearing from the other tradesman. Sadly, that tradesman passed away. He was good, and the community lost a good electrician. But he was probably having a bad day at that stage. You don't know what was going on with the parameters around his personal life as well. So I'm not saying that was just one of my experiences. But you are right. It does, when we have training within the context, and moving over to talking about training within hazardous areas, you have, you do an apprenticeship, and you become a tradesperson at the end of that apprenticeship, and then that's kind of when your experience starts. Like in other countries, as you've mentioned, you go on a journeyman program. In some countries, you're not a tradesperson until you've done at least X amount of years as a journey person. So there's that, kind of rite of passage. After you finish your apprenticeship, there's a rite of passage before you become a tradesperson. Now, if we look at hazardous areas, I can go and do my apprenticeship. At the end of my apprenticeship, I can do a 5-day course, from an accredited RTO in Australia, and I can do hazardous area installs. I tell people, and you might disagree with me with this, but being competent isn't a certificate, because it's defined in the mandatory standard as having the adequate knowledge, skills, and training to perform the task correctly.
Yep.
You can have Yellow Pages book full of certificates, but if you can't perform that task correctly, you're not competent. What are your thoughts?
So, competence, skills, knowledge, and experience. So knowledge, you gain that, right? Whether it be theoretically or practically. Skills, do you have the ability to do it? If you lose your left hand, are you going to be able to be a decent electrician? Probably not, right? You got some limitations. It's the experience. So for example, I was very lucky. Within my first months of doing electrical, while I was working on a casino, there's a lot of heavy industrial. There was a lot of the diesel generators. I got to do more than just commercial grade work. It was tapping into industrial work. We were going to different projects as well. That industrial experience, I believe, is the underpinning that every electrician needs to work in hazardous areas. The problem is I've seen residential guys get their EHA or Compex, or guys go for the Compex in the UK, similar to EHA. 5-day course used to be 10 days, which I believe all training should be minimum 10 days. Companies and industry don't want to pay for that period of time, right? You get a residential guy, and yeah, they don't know how to do point-to-points, insulation resistance measure. They don't understand these things because they weren't exposed to it. The dangers in residential are very rare, are very low. So there's not a requirement for this additional testing and understanding of things. So the industrial experience is needed, but it depends on what industry, right? If you're just in iron ore and all you're looking at is conveyors, drift arms, and belt rip switches, is that going to prepare you for hazardous areas? No,
not really. But you know how to replace some pretty hefty motors, though. But
well, remember, we electricians don't replace the motors. The mechanical guys are lifting it out and doing all that. We just hook up the cable. That's all we do, right? It's in North America. We have I forget the name of it. We have operators that on a plant, they're responsible for the mechanical, a little bit of electrical, welding, all in one. So they're
fitter and turners.
Yeah, we have a different name for it. I'm forgetting the name of it right now. But basically, they're the ones that keep us safe, right? But these guys have a wealth of knowledge, and it's still shared with the electrical. A 5-day course is never going to be enough. There has to be a sharing of what we call in Canada, we call it trade knowledge. How do I know check a cable gland is too tight? I use a cable tie as I'm tightening it up by hand before I start putting the shifter on it, right? And I check up the back. These type of things will never be in a standard. And too many times people go, well, the standard should tell me what to do.
No.
Well, standards are never going to be that prescriptive. That's installation standards, company installation details that, Chevron had them for Gorgon LED, right? And other projects, but not everybody's a massive end user or EPC that's willing to invest that money. So one of the best projects I was ever on, CNRL Horizon, Canadian oil sands, you mine the bitumen from the dirt. So the oil from the dirt. The Australians thought of bitumen on the ground. I'm talking about when it's in the dirt and we got to mine it. We got a little installation handbook. So it went in my front pocket. So if I wanted to know how to install a cable tray vertically, told me how to do it. If I need to go from 90, how to do it, how to mount the junction boxes, how to do the earthing, grounding, and bonding systems. So it was broken down to all the parts and components, down to the lock washers and flat washers, and then the earthing. And so whenever I was the leading hand, one of the guys did something wrong, and I'm like, hey man, what's going on? And he just got really angry, and he's like, you should have told me how to do these things. And so he pulled a book out of his pocket, and I'm like, you mean this page right here? Like you were taught when you got onto the project, this is the answer to everything. If you have a question, refer to this, then speak to your leading hand or supervisor. He hadn't done that. He was a residential guy, used to go, get it done.
Yeah.
That little pocket handbook that the EPC spent a little bit of money on, saves billions of dollars and
crazy.
thousands of hours.
It's absolutely crazy.
From Woodside, we had a little pocket handbook, and it was quite good. But I find that during project execution, majority of projects, there's been nothing. And if there's the specifications and then some installation details, but it's overly too much information all over the place, and it's not shared with the average electrician in the field. How can you expect a person to do a 5-day course and then you want them to go inspect to find all the problems everywhere? Like,
There's
if you have a fluorescent light and the lens is cracked and it's made out of plastic, on Gorgon, we had the major problem of all the guys wouldn't write down that fault because on the ITR it said, oh, is there problems? Blah, 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 glass. They're like, oh, but Mike, it's not glass, it's plastic. And it's like, yeah, like what is the purpose of a see-through layer? To see through. So if it's cracked, you need to tell me. Yeah, but it only says glass on the ITR, Mike. And I'm like, listen, buddy, you have to understand that things are never going to be perfectly how you today. I know I'm sounding like an old guy, but the younger generation wants everything given to them.
the two ones that made me laugh the most is when you see in documentation that all works must comply with like ASN 3000. Or
That's open
it
to
says,
interpretation.
well, no. Like, I love that one. Like, I used to love that one. So, used to have like all works must comply with AS 3000. Yeah, cool, no worries. Your design doesn't. Like, your design is just an absolute pile. You want me to comply to it. Or it says, for any technical support, please refer to manufacturer's specifications. I love that one as well. Like, guys, you don't like, you put in zero effort for this, like, and you're expecting like, you know, us to build the Taj Mahal, and what you're giving us is toilet paper. Like, come on, like, let's all look at documentation and let's support each other through the life cycle of this project properly with the correct transfer of knowledge. That's how I like to say it. Let's transfer this knowledge from our, like, you know, kind of the engineering design is transferring the vision of the end user to the installers who are going to use it.
Let's
And
talk
we're
about the
all,
electrical engineers.
yeah, sure.
Okay, so they go through, okay, in Australia, a bachelor's degree is 3 years, North America, it's 4 years. Is there useless courses involved in the 4 years in North America? Oh, yeah. You have to do other useless things. But I'm sure you've run into that you just said, the engineering. They learn everything about electrical, but they typically do not learn about the national code or standard. So like that electrical engineer, do they learn AS3000 inside and out? Do they learn Canadian electrical code inside and out? No, they don't. We had a lot of foreign engineers, whether it be Canada or Australia, coming in, let's say a project in Australia, and the client specification was 16 millimeter cores feeding these branch circuits for heat tracing. The foreign-born engineer said, no, we only need 1.5 millimeter. I did the calculations based off what? My engineering schooling. Did you apply the derating factors? So in Canada, you know, I would have derating factors of if it's in a cable tray underground in a conduit,
whether it's in tree
what
fall
type
or
of cable?
whatever it is.
Single core, tri core cable. So didn't have any clue about these derating factors. I've spoken to these engineers, UK, Canada, Australia, these foreign-born ones, where they never were assessed against the local electrical standard because it's always, how do we say, excrement flows downhill.
Yes.
It's the electricians, this is all put upon. And so they're told, go install that cable. And we do it. And if anything goes wrong, of course, you know, the electrician will typically get blamed. But there's this gap. I find that electrical engineering, that's where a major gap is. Not only that, in North America, they're used as the supervision. They put them outside for like 2 years as the field.
Superintendent.
For us, so even Bechtel in Australia used them as field engineers. So 2 years as the field engineers, 2 years in the office. And we both know that the best electrical engineers and supervisors are people who move from electrician upwards. They have the practical experience and understand everything. So there's,
The,
I find engineers, I'm just pointing out these gaps that I've experienced and you may have as well.
so with our like so within Zero Industries, within our electrical engineering team, I've spoken to the guys about it. They do touch on like 3,000, so they do touch on the requirements at 3,000, which is
Yep.
great. But as far as derating and cable selection, that's 3008, and
Yep.
that isn't touched upon as much as what it is within an apprenticeship.
Yep.
Because within an apprenticeship on your last year, you're like learning about maxes of demand, you're learning about current capacity and derating of cables, so proper cable selection. And even that is getting the diluted, yeah, because the circuit breaker will control it because the circuit breaker provides that protection against the cable. So
What
you're
about
just going
fault
to
loop
select.
impedance, and then it won't allow the breaker to grip? Yeah.
So but what I'm glad that's happening within our legislation and within our different states and territories lately is there's now a portion that's been called up that's happened in the last like 3 to 4 years. There's now owners on the designers, which is
Yep.
great because you hit it on the head. The electrician is the one who's holding the baby, and I don't agree with that. I think if an engineering if a consulting unit if an engineering consultant or an engineering designer is doing a detailed design or consulting, fine, charge the money, get the price, like get your rates, whatever. I'm all for that. We live in a capitalist society, but do the work, like provide something, and don't and be accountable for that service fee. Like if you're doing classification, classify the thing. Don't put reference to informative portions of the standard. If you're doing the design, select the equipment. Don't sit there and go, put sub clauses within your technical scope that the final design shall be the IFCs that will be provided by the electrical contractor and commissioning. No, like don't take the
Yeah.
money or do the design, and if you're concerned about it, engage the design house of the electrical contractor to validate it. Like do a
Yep.
validation. It doesn't take that. It costs money, yes, because it's time and effort that's required. But do the right thing. That's all I would say to the industry. Like in general, like if you're working, especially within hazardous areas, if you're doing it and you wanna get that premium up here, fine, but do it right, and don't be hiding behind some note or a clause, or you think that you're hiding behind your lawyer either. I know by experience it doesn't work. If you don't do that design right, I'm still sitting in the regulator's seat. I'll have your license like that.
Yep.
It won't take long to be able to figure that you're not competent because you haven't performed the task correctly, and it doesn't take someone who knows what they're doing to be able to find what that is.
Yeah. Obviously, we have our population. We cannot expect everybody equal.
There's going to be bad
everybody-
actors.
Well, what I mean is also the capabilities, IQ levels. We're not all equal. I know there's a drive. I'm not going to get into that, but there's a drive for equality. Like I believe in equal opportunity.
Yeah,
But we are not all equal. We can see that you get 10 electricians, you get 10 of them to do the same thing, and it's all going to be different, even if you taught them all the same way. So it's
but that's more of a like, I don't see it as a thing of IQ.
Society.
I don't. I just think we should be looking more on working and leveraging off everyone's skill set, because everyone brings. I fully believe that everyone goes to work to benefit humanity, and everyone wants to do a hard day's work for a fair day's pay. Like,
there's one of the great things about Australia is upward mobility is very pronounced within Australian society. electrician, you want to do your cert, you want to do your instrumentation, you want to do your EHA, you want to move up. The upward mobility is there. In Canada, it is very restricted as an electrician. Hey, if you're an engineer or a doctor, there's a lack of regulations. So Australia, there's very good upward mobility, but expectations. Everybody passes a course, nobody fails. That's the problem that I saw. EHA back.
It's changed. It's changed now because we had a
RTOs got audited.
Yeah, the RTOs got audited, but it became more about the quality that was coming out of the back end of that, and the industry started complaining about it. So they made changes.
Yeah.
So you used a kind of a self-reporting system that validate your practical application, and based on that, then at the end of your apprenticeship, then you do a test. And so it got to the stage where not so much failed, like it just needed to be more refined. So at the end of each year through your apprenticeship, there'll be like a capstone assessment be like an aptitude test for the things that you've learned. And so it's kind of going, okay, at the end of year one, you should be at this kind of level. You should be able to understand these kind of principles. You should be able to do this kind of work. And so they kind of modeled that. And if you didn't pass it, then you weren't able to proceed into year two. And that's the model that Australia has adopted. And I agree with that model. I think it's a case that I don't think it's a reflection on someone's like IQ, if they can pass or they can't pass it. There needs to be different aptitudes, an entry and aptitude testing in different portions of it. But I do agree that, Australia's the country of opportunity anyway. But I think it's about looking at all facets of the workforce and going, okay, well, what knowledge are they bringing? What knowledge are they bringing? What knowledge are they bringing? Instead of having these isolated individuals or isolated companies that go, well, I'm not sharing my knowledge because that's intellectual property. It's kind of like, well, so that lasted so long, mate. So
I believe we're also training providers, and I don't concentrate on the average technician, right? I truly wish the standards would be more freely available and cheaper. The only way we're going to get the electricians and everybody to actually pay attention is if they actually had a copy. I don't expect that. An Australian, I expect to have a nice cold beer after work, right? I don't expect them to read the standards. But, if they don't have access, as a Canadian electrician, we had to have the code book on our electrical training because the questions were straight out of the code. We had to use the book as an exercise. So I still have it memorized, even 20 years later, right? I still know what sections where I find things. But I find Hazardous areas, there are so many standards, so many, and they're too expensive, way too expensive, and people don't even know how to move through them. If I was working with a government regulator in the US, a common problem that we found is they didn't know how to use it. And even when I showed them how to use it, no, we don't have to follow notes. Oh, what? Notes mean they're just information, and we don't follow notes. In major U.S. regulator, okay, I'm not going to say their name or industry, but major regulator, we don't follow notes. And so it was a nationalistic way of thinking. And while the standard, there's a national deviation of it, they're still not going to read the notes because that's their interpretation. And so, the only way to influence people is the standards got to be cheaper. They have to be cheaper, I should say. I speak proper English. Have to be cheaper and have to be integrated into everybody's training and apprenticeships and engineering from the beginning. That the only way we're all going to be able to communicate is if we're working from a common dictionary and we both have free access or cheap access to the same dictionary. If we're using different terms, here's one I really want to bring up because people are going to question this. In Australia and international, you have earthing and bonding. In North America, you have grounding and bonding. Right there, we are missing one terminology to make it easy. If I look in all the IEC and Australian standards, there's functional equipotential bonding, protective equipotential bonding, equipotential bonding conductor. And when you start looking at the terms and technologies, they all start intermixing and pointing back to each other. But nobody actually knows what any of it means. And they use the wrong terminology because there's 50 definitions I have counted for earthing and bonding in IEC standards.
Few different systems, though, like as you mentioned.
But I'm going to break it down so that it's absolutely simplistic. So, if there's a green-yellow wire inside of a cable, or it's meant to go back to the source of supply, there's your earth. It's for tripping a safety device, such as a circuit breaker, ELCB, RCD, a GFCI, AFCI, AFDD, whatever. It's the one going back to the source of supply. Everything else that is not a current carrying conductor, structure, the surface of the motor, these are non-current carrying conductors, meaning they're not meant to carry current. They're not meant to have electricity running through it. That equipment all must be bonded. I don't care if it's equipotential bonding, structural bonding, whatever. All of them must be bonded. So if I have two different things, they need to be bonded so that they're the same potential. Now, the thing that's missing, where it confuses people, the easy solution is when you start calling it the grounding system. Where's the grounding system? Underground. You must bond.
We don't have
Yeah,
that.
yeah.
Teddy, we don't have.
So the issue is, internationally, you don't use the word grounding. And the vice versa in North America is we don't have the word earthing. So we call it a ground in the cable going back to the source of supply. So I would propose that's always in North America, we should change it to being called an earth. But internationally, everything that's underground is the underground grounding system. So the structure, the skids and the equipment must all be bonded to the structure and together. And then you bond to the underground system. And the earthing is for tripping the circuit breaker. It's the one that's in the cable or the one that goes inside the device. That is for tripping the safety device. Bonding and grounding systems are the path of least resistance if there's any fault. So induced electromagnetic fields from outside coming to the device, or inside, EMC, electromagnetic, basically from inside the device. It creates its own EMF that goes outside. So if you look at a cable and you have a steel wire armor, the cable creates its own electromagnetic field. It goes outwards. The steel wire armor absorbs, right? It absorbs that. But you also have external interference coming in, and it gets absorbed into the armor. So that armor, you have to go to an armored cable gland. So it's bonding the armor to the gland, which bonds to the enclosure, if it's metal. If it's not, you got to use an earth tag, a banjo. And then you need to bond to the underground system. So all the interference, whether it's external or internal or a lightning strike or anything, it'll go to the path of least resistance, the shortest path underground. Now
lightning's a bit of an art form, like for LPI systems. They're different kettle of fish.
The LP, the lighting protection systems. If all your structure is bonded and all the equipment is bonded together and then bonded underground, the lightning protection system still has some continuity, right? You'll still have stray currents. Yeah. But that's the whole point of bonding everything. But when we all talk about earthing, grounding, and bonding, every country has this problem where we're only using two of the possible three terminologies, and it's confusing. So, and I see it in Canada, US, UK, all throughout Europe, Southeast Asia. We go to a facility, let's say Turkey, and they go, yeah, we did all the earthing, grounding, bonding systems. How'd you do it? 60079-14. It doesn't tell you how to do the earthing, grounding, and bonding systems or lightning protection. It refers to another IEC 60364 series -6, which is AS 3000 section 8. Okay. Exactly copy paste with some changes. They're like, no, we didn't follow that. And I'm like, well, Dash 14 tells you to go there. Did you go to Lightning Standards 62305 and then look at Annex D? They're like, what? And so you look at their earth and grounding bonding systems, and I see it where they'll take one bond from underground from the grounding system, and then it just daisy chains across multiple skids. They don't understand the basics, but
it
the
gets back
people
to
creating.
it gets back to that test, like the testing of it though. So, especially like with earthing, I have a friend. I have a friend who works for like one of the water entities, and the earthing. They have a dedicated team that just works on their earthing systems and also their testing of their earthing systems for all of their assets within their catchment areas, because it's from my perspective, it's a science. Like to get it right. When you're talking about underground systems, especially with water treatment plants and that kind of stuff, you got to make sure that it's right. But on no, like I've seen like guys that just go, oh yeah, like let's just look and get like a 35 in bare earth and just go on a daisy chain. But then it's a case that that may work in that may. I'm not saying it would. I'm saying it may work, but you've got so many points of failure along that system, and you're not testing it properly either. You're not like, where is this going downstream? You're just looking at it and going, oh, it's just an earth, like, but it's not. There needs to be the correct amount of like design, the correct amount of like a case study for it, a feasibility study for it to go, okay, well, how long is this particular project or how long is this site going to be in operation for? And then go, we want to have a lifetime, a time horizon that we can make sure that our systems are designed in accordance with the standard today, but will have some form of sunset in 30, 40 years. Or, we'll have, we know that the time will change, we know that standards will change, we know technology will change. We need to have that flexibility with what we have today in order to accommodate for those changes. But we want to make sure that we've got it to people. I find that like when the argument, not so much the argument, when the discussion comes in, oh, we want to comply with this standard, great, like we're all for that. Mandatory standards, let's all comply with that and the world would be a little bit better place. But you're arguing about a minimum requirement. Like you're having a discussion about you just want to meet the standard, like meet the standard by all means. But like if you are in a position where you can influence the company, the standards are foundation. Like let's build the structure around it. Let's create, as you mentioned previously, you had a workbook that enabled you to say this is exactly what you're going to do. Like those kind of operation manuals, there's manuals to support end users or to support installers or to support maintenance personnel. That's where it all stems from.
And as you said, the standard is a minimum, but it can be applied in dozens, multiple different ways. And if you do it one way, typically it can cause an issue. So that's a problem in industry where we don't, the offshore standards, IEC 61892 or MODUs, mobile offshore drilling units, are much more clear. Gives you exact prescriptive methods of how things can be done. Earthing's one of those things where we really should design it like for underground systems or above ground should be one of two ways. And if you want to that's my view, because we waste so much time, effort, and money with earthing, grounding, and bonding systems. And the majority of people don't understand that, okay, there's 13 sources of ignition, electrical equipment faults, stray currents, lightning, electromagnetic fields, radio frequency, blah, 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 blah. So basically 7 of the 13 sources of ignition are taken care of by good earthing, grounding, and bonding. And let's say Netherlands, they love to use metal, intrinsically safe devices. Their cables, intrinsically safe, will just be twisted paired. Sometimes no shielding, no armoring. And then they use a PVC gland and nobody attaches the bonding on the external of the device. They go, oh, no, it's not a worry. And it's, they don't understand.
So we have a mandatory requirement within Australia is to comply with AS3000 being a mandatory standard. But within AS3000 or ASNZS 3000, sorry, section 1.7, that deals with selection and installation of electrical equipment. And with a lot of people in hazardous areas, this is what they get pinned on, or a lot of people that don't install stuff. It's like, this is, if you don't install something correctly, like 1.7 is what you defect for, or even like a rectification order for. And it's the equipment shall be selected and installed as per the manufacturer's instructions.
And what happens? Read those instructions.
That's what I'm getting to. So within, and then if you go from a hazardous area perspective, there's a portion within all of the inspection requirements within Part 17, like 60,017 Part 17.
And that 14 tells you the standard is based on you following manufacturer's instructions.
Correct. So that's what it gets back to. So intrinsically, and it always happens with instruments. Intrinsically safe instruments, I wouldn't say a high majority of them, but some people who don't read them just like connected cables into it and it's all dark. It's kind of like, okay, where's the potential equalization bar? It's missing. But then if you have to go to the manufacturer's instructions, because that device needs to be bonded in such a manner. And if it is bonded, it will say that it requires like an isolation peg. So you need to get an isolation stand for it. So the device, so you won't get any interference lead back when you're doing your calibration of your SCADA or like your commissioning of the device. And so you go, okay, well, what happens is people get complacent and they look at the device and they go, okay, well, the device is the device. But what they don't understand is the manufacturer, that housing for that device is just, they do so many different configurations, but they use the same housing. So each individual instrument is different. So the installation requirements, you need to look at it and go, well, what device have we got? What are the implications of that device? What does it say in the what does it say in the engineering design? Then go, okay, how do we connect this device correctly so that it operates? So it's like it satisfies the requirements for fit for purpose. And then what are the other parameters that we need to ensure, like, there's an earth tag on it that has an earth sign on it. It's a bolt on the outside. Is it connected? 9 times out of 10, no. Why not?
Yep. And, I had these discussions with Australian companies.
Oh, the circuit earth is fine. Oh, it's bonded. Yeah, it's bonded.
They don't understand the difference. Yeah, they don't understand the difference between earthing and bonding. Earth is for tripping the safety device, but the bonding is to protect from internal and external interference. Not only can it induce a possible, but also if your instrument is not working correctly, Boddington Gold Mine, belt splicers were working, but nobody isolated the weightometers. Because a motor started nearby and the shield drain was not insulated, floating at the instrument, instead it was making continuity with the enclosure, you had circulating currents, right? So because we communicate at 420 milliamps, it's quite easy to hit that. Well, whenever motors were starting nearby, it started showing that there was iron ore on the belt. So the operators started screaming on the radio to shut down the belt. They were thinking that the belt splices were going to die. And it all came down to, well, the installers and maybe the designers told them to do it the wrong way. But the point is that people don't understand the importance of electrical isolation of the shields, the shield drains, the intrinsically safe system. All of these separate things need to be electrically isolated, but also the armor and the cable gland of the device has to be bonded so that if there is any interference, it goes the path of least resistance. So we don't create a spark and we don't cause the instrument to give wrong readings. Because if an instrument's giving a wrong reading, we could end up having an ESD. Like all of our facilities run due to instrumentation. If something goes wrong with an instrument, something as simple as induction, because nobody installed a bonding wire, it can create ignition, or it can cause an unplanned shutdown, which can also create an ignition. So there's a Swiss cheese effect. There's knock-on effects to these things. And so that's why I brought up the earthing, grounding, bonding. The 7 of the 13 source ignition can be alleviated. But like fluids and gases flowing through lines, that creates a static charge.
Mm-hmm.
And so many people don't understand that. And we do a lot of seawater uplift to inject into oil wells offshore, so it lifts the oil up in the oil reservoir, right? Seawater running through an ABS pipe, that creates a lot of static. So we actually installed ground earth rods directly into the process stream where the seawater was going. Because all the static that is built up, we want to drain it away. Well, Australia should be well versed in the dangers of not having good earthing, grounding, or bonding systems. Varanus Island. Cathodic protection system was not maintained, meaning somebody wasn't doing the point-to-point endeavoring. Nobody did the inspections, or nobody knew how to do it properly. I've been out on other vessels offshore in Africa where the metal is delaminating like wet cardboard. I believe I've shown you before. Steel structure just coming apart like wet cardboard. Earthing, grounding, bonding. What do you do at that point? So you have a difference in potential.
Put a caterpillar around it. Yeah, it should be fine.
So you have all these differences in potential, even the person themselves. And it's a completely, I find within industry, people disregard earthing, grounding, and bonding utterly too much. There's experts in Australia where I call out their posts on LinkedIn just for how bad it is. Gas lines to businesses, commercial, residential. There'll be a mechanical device, and there's no in the process line, and it's not bonded. And if there's not metallic gaskets between the joints, how are you getting that maximum, ensuring no more than 10 ohms, maximum resistance through any mechanical structure? Internationally, we say your lightning protection system's maximum 10 ohm, but each section of it, maximum 1 ohm. Every skid, if I have a package in a plant, I should be able to go to the top of a vessel to a bolt and measure from there to the earth bar, bond bar, and get maximum 10 ohms. And all of my bonding conductors, maximum 1 ohm. Well, in Australia, it's 0.5 ohm for the bonding conductors. But people don't even get this. And so then even in industrial and commercial, when you bring these points out, they'll get aggressive and go, oh, I follow this standard. I'm like, okay, let me download that standard. Did you follow this clause? Yes. How'd you follow it? They truly never read it before. They didn't follow. They didn't read any of the instructions. They didn't do the easy things like install a bond. Installing a bond, man, make up some whips. You make up a 1 meter bond, 6 millimeter conductor, and you have a box of it. And whenever you go to an installation, you just grab them, put them in. Such an easy thing that makes everything safer. But people will find
that's because of that's just a telltale sign of the retainment of information. People feel that if they let go of that information, that their purpose or whatever it is just degraded. And it's like, guys, we're all doing this for the same reason. We're all giving out this information. We're all here to provide a project, and we're all here to make sure that at the end of the day, we can come to work, do a good day at work, go home and be safe. Let's just let's have some discussions, and the discussions might be heated and all that kind of stuff because we've all been in those. But let's just leave our egos in the door and look at what the goal is here. But it's not money, it's not ego, it's people's safety at the end of the day.
Let's drop some human psychology. 99.9% of all factors of anything ever failing is human-induced faults. It wasn't designed properly by a human. Unless, if you have a good lightning protection system and the lightning still causes a problem, act of God. Okay. But 99.9% of the time, somebody screwed up. And the thing about people, we all love to say no, and we love to never admit fault.
No, okay.
Like, hey, can you help me with this? No, mate, I'm busy. Did you do it? You know, everybody loves to say no. And even when you point out something that's wrong and you come from, you know, a polite way of saying it, it's like, hey, man, I think you have an issue with this. They'll immediately, nah, mate, you're wrong. And they'll refuse to listen. And you just can't. You can have the I'm having a conversation. They're having trying to nuclear war. But
so it's probably also like, if I would have seen that when you were in Australia as well, because of the like
corner.
Yeah, like, and they would have been like, oh, even though you're from Canada, they would have misassumed that you're an American. They would have been like, oh, American loyalty, no,
Oh man,
throwing its
I
weight
would ask
around.
questions like, hey, why do you guys do
No.
this way? And they go like, my F off, go back to Canada. You know, they wouldn't want to explain it, and they'd get angry.
Like,
and I'm like,
yeah,
I'm,
we do.
I'm trying to understand you so
No,
that
yeah.
I was, but I'm not saying not all Aussies are like that. Okay, you're like, we have discussions on the side outside of this podcast, and we have disagreements, but we try to give a different perspective.
It's more about I think, like, especially for foreigners coming into the Australian market, like, and this isn't been like, this podcast isn't just specifically around Australia, it's around Hazardous area, because we have that international harmonisation. But like, when we have, it's not so much now, but it was back in the day, like, was more arrogance about, oh, this is the Australian way of doing it. That kind of argument's gone, been settled, because we are more open to learning it. There's more adaptability and more modification from international standards, and not seeing Australia as like a isolated island in the South Pacific, but seeing it as kind of a player in these particular portions. We've kind of got to wrap it up soon. So, a couple of things. We've got the IDC conference coming up. So you're one of the keynotes. So what are you going to talk about?
I'm going to talk about everything about hazardous areas, about practical solutions to common problems, talking about hydrogen. I've been involved in a few projects, but I'm not hydrogen in the way forward for everything. I have enough practical experience to know the limitations, but I'm not going to always put those out there to industry. They got to figure things out for themselves. But there are easy practical solutions, and one of them is bringing the knowledge of mechanical hazardous area requirements and the dangers of it. The last EHA hydrogen conference, 3/4 of the attendees were mechanical. So it really is, there's a drive for that knowledge. And as we've all experienced on every single project around the world, there's always a divide between the electrical and mechanical. They build a metal structure, but if they don't install the bonds on the structure, we can't do the earthing, grounding, and bonding. If we start welding on their structure, they're going to complain. So it's this give and take. So the presentation is there to help provide a bridge between the trades, between the different industries, and providing practical examples of how to get over these common industry issues that they experience. Because I come from those industries and experience those problems, and I want to help the industry. Let's not keep repeating the same mistake and wondering why it keeps happening, or thinking that it's only happening to you. There are easier, better, cheaper, quicker, better, faster, stronger ways to do things, and so coming with that, so practical solutions to hazardous areas, mentioning mechanical ignition sources, and also hydrogen. So kind of touching on many different things from a practical perspective, but also being able to back it up should anybody have any questions with standards references and other project examples. other example projects.
Sounds good. Looking forward to it. So one last plug. If people want to find out more about you and what you do, where can they find you?
So LinkedIn, easiest possible way. Mike Marrington, M-I-K-E, Mike Marrington, M-A-R-R-I-N-G-T-O-N. Company is Index. So www.ind-exae for Abu Dhabi. We have a couple different locations. LinkedIn, always easy way to reach me, and also via our website. Send an email, michael@ind-ex.ae. We operate globally. Just in the last month, I was in Pakistan, Israel, UAE, Senegal, Europe, and so all over the place, not limited, and also do projects in Australia as well.
Fantastic. We'll put some links down in the description below so people can find you. And yeah, looking forward to seeing you at the conference. And yeah, thank you so much for spending the time to have a chat with me today.
Cheers. Thank you very much. We appreciate it.
No worries. See ya.
Have a good one, Travis. Thank you.
So